Hey guys, welcome to our channel Code with Coffee. So let's move towards our today's video. So today we are going to learn about the bubble sort algorithm. It's an sorting algorithm. Okay. So what actually it is, we will see. So I have created here an array. So this 7863921 is an array. I am showing it in the form of bubbles because we are learning in bubble sort algorithm. So we are just sorting this array into like 7863921 into 1236789, okay, in that format. So we are sorting it. Okay, so now I am creating whatever I am showing you in front of you in a pictorial format. I am converting into the code. Okay, so actually it was an array, so I am creating the same array in our C code. Okay, so let's come towards the code. So here I am just creating an array named as ARR because we have 7 elements in the pictorial format. That's why I have created here in 7 element. So what are these 7 elements? 7863921, 7863921, and 1. So this is our array, and what we have to do, we have to sort that array. So after sorting, how it looks like, it looks like 1 2 3 6 7 8 and 9. Okay, so this is the array given and we have to output that array 1 2 3 6 7 8 9. Okay, now I am showing you what we are going to do actually. So just I have created that array 7863921 which is shown here. Now I am showing you how it converts, how it bubble out that 9. So you are seeing that 9 and I am bubble outing that 9 and put it at the last. After that I am bubble outing that, I put it here second last. After that bubble out 7 and put it into the third last. So in that format I am just bubble outing an element and put it in the last element. So first it get choose the maximum element from the array, like here is the 9, and put it at the last. So it does the things repetitively. First it bubble outs the 9 because it was the maximum. After that it looks into that much array of the 6 element and bubble out the 8 and put it last. So in that way it does the same thing again and again. So we have to use here for loop. So actually I want to show you how it works. So first it compares 7 and 8. Here 7 is less than 8, that's why it do not do anything. After that 8 in 8 and 6, 8 is greater than, 8 is greater, that's why it swaps it. Again in 8 and 3, 8 is greater, then again it swap it. Okay, now in 8 and 9, 9 is greater. Okay, so that's why do not do anything. Okay, after that in 9 and 2, 9 is greater, that's why it swaps. In 9 and 1, 9 is greater, that's why it swaps. Now you can see how it bubble outs the 9 and put it at the last. Okay, so in the same way in the next iteration, first what we are going to do, we are just writing a code for bubble outing a maximum element and putting it for the single iteration. Then we see what to do for the next iterations. Okay, so just come here and do the coding for just a single iteration. So actually what it does, it compares the first two element. Okay, if the first element is greater than the second, then it swaps it. Otherwise, if this condition not satisfies, then what it does, it actually do nothing and go forward. So we have to do the same thing. We have to compare the two elements. If first is greater, then we have to swap, otherwise we do not need not do anything. Okay, so right here I am just writing here code because it what it does, it compares 7 and 8. then compares 8 and 6, then compares 6 and 3, then 3 and 9, then 9 and 2, then 2 and 1. In that way it compares 1, 2, 3, 4, 5, 6 times only. The elements are 7 but it compares 6 times. So that's why I am writing here I is equals to 0, I is less than 6, 7 minus 1. If you have the array of 10 elements, then you can take here 9, because it compares only 9 times. Here it compares only 6 times. So I am writing here 6 and I plus plus. So this is our loop for comparing it 6 times. Now for each compare like 7 and 8, it checks the first element and second element. If so, first element is array of I, suppose, and second element is array of I plus 1. So if this condition satisfies, then we have to swap. What we have to do? We have to swap. So how we are going to swap here? Just this 7 is inside the array of I and 8 is in the array of I plus 1. Assume that 7 is here and 8 is here and 7 is greater than 8. Otherwise we are going to write for that 8 and 6, because we do not, this condition not satisfies for 7 and 8, so it not works or runs that if condition. So it just go here and breaks the loop and go forward for the 8 and 6. So for 8 and 6, 8 is greater than 6. Okay, so array of I, that means this 8. Here condition of I is converted for the 0 for 7 and 8. If I is 0, then array of 0 is 7 and array of 1 is 8. So there is no any problem. But if I is 1, then at that time array of 1 is 8 and array of 2 is 6. So here we have to write the code actually. We have to swap, go move that 8 in the position of 6 and move the 6 to the position of 8. So that's why I'm writing here what we are going to do actually. We are just swapping. So to do the swap, I am declaring here one integer a and passing that 6 inside the a first, or 8 inside the a. Then inside the array of 1 we are passing 6. Okay, now array of 1 is consist of 6 and array of 2 both are consist of 6, but we have to change array of 2 to 8. So that's why again I am what going to do, I am passing array of 2 is equals to a. So that a 8 I am storing initially inside that a and again passing it into the next position of the array. So here I am writing a is equals to array of I, that is I am putting that 8 inside that a. After that I am adding 6 instead of that 8. So to do that I am adding here array of I plus 1. So what it does, it actually put the 6 inside the array of I. Now 7 6 6 in that format it looks, but we have to make that 6 as a 8. So we then add a in the next position. Okay, so now I am first I have make that it 6 and then make it 8. Now the array look like 7 6 8 3 9. Okay, so in that format it works. So this is for just moving that 9 at the last. What it does actually, it just pop out that 9 and put here. Now we have to put 8 here also, 7 here also, 6 here also. So what we do, we will see in the pictorial format. So what it does, it compares 7 and 6. 7 is greater, that's a swap. Again 7 and 3, 7 is greater than swap. Okay, now 7 and 8, 8 is greater, so that's why here no swap happens. After that in 8 and 2, 8 is greater, that's why it have to stop swap. Again 8 is greater than 1, that's why it have to swap. Now the position of 8 is get fixed, then again next iteration start. So this iteration condition, that is the moving the largest element at the last, this process continues again and again. First it do works or iterate for the 9, then for the 8, then for the 7, then for the 6. So it works for how much times? It works for 7 times. I will show you again. Now for 9 is completed, for his 2 times it already completed. Now we will watch for the third time. So what happens for the third time? Now third time iteration start. 7 and 6, no swapping. 7 and 2, it swaps. Again 7 is greater than 1. That's why it gets swapped and 7 come before it. Now this iteration is completed. Now next iteration starts. So this was the third iteration completed, fourth start. Swaps, because 6 is greater than 2. Now here 6 is greater than 1, then it swaps. And after swapping, fourth iteration is also completed and fifth iteration start. Next iteration, that is fifth. Now 3 and 2, it compares. 3 is greater than 2, then swaps. Again 3 is greater than 1, then swaps. Fifth iteration is also completed. Now the sixth iteration. 2 and 1, it swaps. Okay, and actually the seventh iteration is for that one only. So that's why we are iterate it for the 7 times. So I'm running that same code for the 7 times. So that's why I'm just writing here for integer j equal to 0 semicolon j is less than 7 semicolon j plus plus. Okay, so I'm just writing it. So what it does, it do the that same thing for the 7 times. That's why the complexity of that code is n square, because it runs for the n minus 1 times and it runs for the n times. So n into n minus 1, which was n square complexity, big of n square complexity it shows. Okay, so we'll learn about the complexity in further lecture, but now the complexity of that bubble sort algorithm is n square. Now for integer I equal to 0, I'm writing it for just printing these 7 numbers. I'm just printing the array only, do nothing other than that. So that's why just printf %d comma array of I, and just to separate 7 8 from each other, I'm just writing here a space, and that's it. Now I'm running it. What it will show, so it just sort 1 2 3 6 7 8 9. Okay, so it what we have to achieve that thing, and this will be achieved by just that bubble sort algorithm, which shows the complexity of that bubble sort